Hello and welcome to all to the lecture. It is on basics of thermodynamics, introduction and basic concepts. So let us start. First of all, we need to know what is thermodynamics. Thermodynamics is a branch of a science which deal with energy transfer and its effects on properties of the substance. Properties can be physical property as well as chemical properties. The amount of a heat or work transfer taking place while arriving at one state from another is the main concern in thermodynamics. That means that how much amount of heat transfer taken place, how much work transfer is taken place while arriving at one state from another is the main concern in thermodynamics in terms of energy of substance, joule, kilojoule, etc. Then we have two important terms known as system and surrounding. What are those? What is system? It is a fixed mass or region in a space control volume where our study is focused. Basically, it is that part of the universe where our study is focused. We have another term known as surrounding. Everything external to the system known as surrounding means that part of the surrounding which is affected by the system is known as the immediate surrounding. Okay, I hope this is clear. Let us move. We have classified system into three categories. One is closed system, one is open system, and third one is isolated system. What is closed system? Closed system, it is a type of a system in which only energy interaction and no mass interaction take place. Example is piston cylinder arrangement without valves, means no mass can enter or no mass can leave the system. However, energy can enter or energy can leave the system. That is a closed system. Then we have an open system. What is it? Open system, it is a type of a system in which both energy and mass interaction take place. Means energy and mass can enter into the system and also can leave the system. That is known as open system. Example is piston cylinder arrangement with valves. Then we have third category, isolated system. What is it? Isolated system, it is a type of a system in which neither energy nor mass interaction take place. Example is hot coffee or tea kept in a well insulated thermos flask universe. Means when the hot coffee or tea is kept in a well insulated thermos flask, neither energy nor mass interaction take place, and thus hot fluid remains at a relatively hotter temperature in a very long period of time. But ideally, thermos flask cannot be considered as a isolated system because after some time it will lose heat eventually. That hot fluid will become normal. Thermos flask cannot be considered as a completely isolated system. It is somewhat isolated but not completely. One more example is universe. The whole universe is an isolated system. Then we have boundary. We have system and a surrounding, and a part or the surface which separate them is known as boundary. It can be real or imaginary, or it can also be fixed and movable. Let us move on further. What is a property of the system? Any characteristics of the system is known as the property of the system. It can be pressure, temperature, volume, enthalpy, entropy, anything. Then we have classified those properties into two categories, extensive property and intensive properties. What are those? Intensive property. Intensive property are also called as intrinsic properties, properties which are independent of the mass of the system. Example, density, temperature, pressure, etc. These are known as intensive property. And another classification is extensive or extrinsic properties, which are those properties which are dependent on the mass of the system. They are known as extensive properties. Example, volume, enthalpy, entropy, kinetic energy, potential energy, etc. All the specific properties are intensive or intrinsic properties. What does it mean? What is specific property? Any property per unit mass is known as specific properties, and when we consider any property per unit mass, that means it become independent of mass. Example: specific volume, specific enthalpy, specific entropy, etc. So the property which reduces on partitioning of the system are known as mass dependent property or extensive properties. On the other hand, the property which remains same even after the partition, they are known as mass independent properties or intensive properties. I hope this concept is clear to you. Okay, then we have some key points with respect to properties. What are those? They are point functions. Point functions means thus depend upon the final position and the initial position or the final or point or initial point. They are exact differential means their value is the difference of their value at the final position and initial position. They are independent of past history. That means that their values of the properties are not influenced by the post part. Means if we consider any property in a system, so that does not influenced by an independent of part history. Then we have state. What is it? State: any condition of the system is known as the state of the system. Any condition means specified pressure, volume, temperature, anything we have specified that become a system. Okay, what is a process? It is a change of a state is called process, which change any one property of the system and that become another state, and that change of state is known as a process. And what is a process path? The infinite states through which the system passes while going from initial state to final state is called as a process path. Process path can be constant pressure path, constant volume path, constant temperature path, adiabatic path, anything can be that would be specified. Then we have classification of processes. Processes are broadly classified into two categories. What are those? Quasi-static and non-quasi-static, and reversible and irreversible. Quasi-static process. It is that kind of a process that occurs infinitely slow and they are represented by joined lines on the property diagram. Then non-quasi-static process. It is that kind of a processes that does not occur infinitely slow and they are represented by dash line on property diagrams. Then we have another classification: reversible and irreversible. What is those? Reversible process. It is that kind of a process which can be reversed in direction following the same path and without leaving any effect on the system and the surrounding. On observing the statement, you will find three conditions. What are those? Reverse in direction, following the same path, and without leaving any effect on the system and the surrounding. These are three conditions. If all these conditions are satisfied, then only we can say that the process is a reversible process. Then we have irreversible process. It is that kind of a process which is not reversible. These three properties are reversed in direction following the same path and without leaving any effect on the system and surrounding. If any of these process properties is violated, any one or two are violated, then we can say that the process is not reversible. So for the process to become reversible, all these three conditions need to be followed. Then we have some important points. All quasi-static processes are not reversible, but a reversible process is always quasi-static. Means what is quasi-static process? That occurs infinitely slow. If a pressure is occurring infinitely slow, that does not mean a reversible for a process to be reversible. Those three conditions which I have told you in the earlier slide need to be followed, and if any process follow that three conditions become reversible and it is always quasi-static. Quasi-static process, compression and expansion of a gas is reversible process. Macroscopic and microscopic analysis. In this analysis, average molecular behavior is taken into consideration. We will not take individual molecular behavior. We considered average molecular behavior, how the molecules are behaving on a whole on average basis. That is our main concern in macroscopic analysis, and this approach is valid till the concept of continuum hold goods. The mean free path of the molecules is very much less than the system dimension. Okay, what is mean free path of the molecule? Mean free path of the molecule means the distance traveled by the molecules between successive collision, and if that distance traveled by the molecules between successive collisions very much less than the system dimension, so it is known as concept of continuum is valid. In that case, we will consider macroscopic analysis and average molecular behavior will be taken into consideration. Okay, on the other hand, when the system become rare, means when the mean free path of the molecules is the order of system dimension, then the individual molecular behavior is taken into consideration, and that is known as microscopic analysis. Properties like pressure, stress are valid when the concept of continuum is valid, otherwise they are not valid. Okay, I hope this concept is clear to you. Then we have pressure. What does it what are the causes of pressure in gases? Pressure in gases is due to forces occurring because of colliding molecules with the surface, and it act normal to the surfaces. Pressure is a function of a density and temperature. What is density? Density is directly proportional to the number of molecules colliding. More number of molecules colliding, more will be the density. Next, colliding velocity is directly proportional to temperature. C. According to kinetic theory of gases, that is, root mean square velocity is given by root under root 3 RT by m, where R is realistic gas constant, T is temperature, and m is mass. And then liquid. The pressure in the liquid is due to repulsion between molecules. In the liquid there is a repulsion between molecules, and due to that their pressure exists. Okay, then we have thermodynamic equilibrium. What is it? Thermodynamic equilibrium consists of four equilibrium. What are those? First, thermal equilibrium. Second, mechanical equilibrium. Third, chemical equilibrium. Fourth, phase equilibrium. For the system to be in thermodynamic equilibrium or complete equilibrium, all these four must be satisfied. If any one of them not satisfied, we cannot say that the system is in thermodynamic equilibrium. Okay, what is what is thermal equilibrium? Thermal equilibrium means equality of temperature. If the temperature are not equal, then there will be a heat flow within the system. In that case, we say that the system is not in thermal equilibrium. Then mechanical equilibrium, that means equality of forces or the forces arising due to pressure. That means pressure should be same and each and every point of the system. With the time means the pressure should not change with space or pressure should not change with time. Then we have chemical equilibrium. What is it? Chemical composition should not change with time. That means within the system chemical equation or chemical reaction should not take place, and if that condition is satisfied, we say that system is chemical equilibrium. Then what is phase equilibrium? Mass of each phase should remain constant with time. That means if a system is comprising of more than one phase, then mass of each phase should not change with time. If that condition is satisfied, we say that system is under phase equilibrium. So that it is for this lecture. Thank you for watching this lecture.